Good day and welcome to yet another of our discussion in inorganic chemistry. Before we start, we want to remind you that we've done a few posts on YouTube and Google Drive. The Google Drive link that you can reach to the page is as posted after every video. You will go to the comment section of every clip that is of interest to you. There in the comment section, you will see the link for you to obtain the PDF format of every video we make. Today again, as I have said, we're going to make another presentation. At the end of this presentation, you'll be directed to obtain the PDF format of it in our Google Drive through the link that will be posted in the comment section. We want to discuss crystal field theory. There are various phenomena that discuss or describe the coming to stay together of atoms to form bond. We had earlier discussed valence bond theory. Now we want to discuss crystal field theory. Crystal field theory is a model that conceives bonding between the metal center and the surrounding ligands as a strictly electrostatic phenomenon. Electrostatic meaning that it is made of the positive and the negative component. That is to say that in the view of crystal field theory, bonding arises strictly as a charge separation or ionic phenomenon or interaction. It describes the breaking of the degeneracies of electronic orbital. Recall that when we discussed valence bond theory, we told you hybridize degenerate. By degenerate, we assume or we take it that all the combining orbitals are at the same energy level. But that is not the case with crystal field theory. As we go on, you see that with the approach of the ligand, the fields to be so combined, which in crystal field theory, he only considers D. He has nothing to offer in the S and the P. And when we go to the merit and demerit, you see us discuss that. He says that the 5d orbitals by the approach of the ligand shall be split into two suborbitals, the Eg and the T2g orbitals. The Eg and the T2g orbitals shall have differential energy level, by which in crystal field theory phenomenon, the degeneracy does not hold. And for this, he assumes, or the theory assumes, that the metal center is seen to maintain a positive disposition. That is, by it, the metal center is usually and always permanently positively disposed, whether or not it is a neutral metal center or a cationic metal center. The concept of crystal field is that the metal center is a positive charge and the approaching ligand to the metal center takes a negative disposition, whether or not the ligand is an anion or a neutral atom. For instance, when we talk about an anion, we are looking at the halides, chloride, bromide, iodide, and all of that, which shall have accepted electron to become an anion. If it comes in, true, it will take its natural charge dispersion. But assuming we are looking at ammonia or water with their lone pair electrons, the view of crystal field theory is that if any of the neutral ligands wants to approach the metal center for bonding, he shall orient itself such that the electron cloud that forms the lone pair electron will be directed at the metal center orbital so as to cause the split and therefore induce ion dipole attraction. There shall be a charge separation. So long as there is an approach of a negative charge towards whether neutral or cationic metal center, there shall be what we call ion dipole attraction induced. So we will see this in the schematic here presented. You can see the yellow ligand approaching the metal center from in between two lobes, the two green and white lobes is being approached from in between. The ligand is approaching the metal center from in between. Electrostatic field of the ligand approaching the metal center from the in between orbital causes a split. You agree with me? Even if you fold your hand and you force your finger through your hand, you see that the hand will be caused to expand. If you take a nail with a piece of hammer and nail into a piece of wood, you notice that the wood will be caused to contract to allow the wood will cause to contract to allow the nail to enter. This is the same thing that happens here. But in crystal field, two phenomena come to play. It is either the ligand approaches the metal center from in between or directly head-to-head collision. So there is a change in energy as the ligand is approaching, causing a split in the degeneracy of the metal center. This is clearly shown on the structure to your left, where you see the yellow ground state, the yellow ground state, 5d orbitals of the free metal in its degenerate state or ground state. Upon the approaching of the ligand, there is excitation. Excitation will occur and there will be a rise in energy. There will be a rise. You can see the energy profile. When excitation occurs, the orbital of the metal will be caused to split, As you can see, there is a split into the EG, which is the two higher orbitals, and the T2G, T2G orbital, which is the three lower orbitals. And the differential energy is as shown as 0.6 positive or 0.4 negative. As you can see, there's a rise in energy away from the excited state, and there's a drop in energy away from the excited state, where you have the dx square minus y and the dx square minus y square and the dz square orbital to the eg orbital or higher orbital, the plus 0.6. 3 over 5 will give you 0.6 positive, higher than the excited state, and 0.4 negative, which is lower than the excited state. So that is what crystal field explains when we talk about the breaking of the degeneracy of the metal center as the ligand approaches. Furthermore, there are factors that affect the orbital splitting. It is being affected by the nature. The nature, we've said it here, the nature. Is it a free metal that has not lost any of its valence electron? The electropositivity and electronegativity disparity of the metal center determines the splitting. Furthermore, the oxidation state, if it is a cation indeed, remember we had said it assumes a cationic tendency. But if it is a true cation, a higher oxidation state shall lead to a larger split. You certainly know that negative, positive are never friends. But if it were not a cation, as we had said earlier, the split will be differential. The arrangement of the ligands too, which is the spatial dispersion. We mentioned spatial dispersion in one of our topics, that it shall enter the metal center through a definite angle, a definite angle. So that's what we call spatial dispersion, which gives the geometry, which gives the shape, geometry shape of the resultant complex. You have a linear complex, you have a trigonal complex, you have a square planar tetrahedral, and all of that. So the arrangement too, if the metal center is overcrowded, the inversion of the ligand into the orbital or into the coordination sphere shall be distorted. You call you call that overcrowding, overcrowding. And all of these determine the nature of the ligand surrounding the ion. There are the strong and the weak field ligand, and there are the bulky and the small ligand. So, depending on the nature of the ligand, these are those factors that may affect or that will affect the entrance of a ligand into the metal coordination sphere. Now, what are the merits? What are the merits and the demerits of crystal field? The combination of the crystal field with molecular orbital yield a reasonable argument for chemists when coordination compounds are discussed. But on its own, the theory has been used to describe various spectroscopies, that is, various colorations. So the optical spectra of the complexes have been reasonably discussed satisfactorily by crystal field theory. It has also been able to account for the magnetic property. Do not forget, so long as we talk charges, there will be induced magnetic, induced electric field, and all of that. So crystal field theory has been able to satisfactorily discuss the magnetic and spectral properties of complexes. Like it is always said, to everything that has a merit, there's always a demerit. So the assumption that interaction between metal and ligand is purely electrostatic is clearly misleading. We cannot assume everything to be electrical. No, it cannot. So that assumption is misleading, not allowing us to take cognizance of any other kind. So the demerits of crystal field that every interaction between metal and ligand is electrostatic is misleading. Like we had said at the beginning, he has this theory has looked at the splitting of the 5D supposed degenerate orbitals. It has not taken cognizance of the S and the P. He has not taken cognizance of the S and the P, which is also not tenable in chemistry. Further on, like we said, we have the strong and the weak ligand, which will split differentially. It will split even the acclaimed 5D orbitals differentially. But this theory has not taken cognizance of why there is a differential split in the metal center by different ligand. The theory totally rules out the possibility of having a pi bond. Remember, when we talk of the head-to-head and the side-to-side orbital overlap, head-to-head is supposed to give us a true sigma bond, a true covalent bond. But the side-to-side is supposed to yield or yields a pi. But here, he does not take cognizance. Crystal field theory does not take cognizance of the formation of pi bond while in the splitting. This theory gives no significance to the orbitals of the ligand. He doesn't give any credence to the orbitals of the ligand as it comes in, and he cannot account for any property to the ligand, any property related to the ligand and their interaction with the metal. So at this point, you realize that the crystal field theory differs a little from or differs from the valence bond theory earlier discussed in the perspective that he assumes everything is electrical. Electrical, it is either positive and negative or nothing. And this is very misleading in chemistry. At this point, we want to remind you once again to visit our PDF platform in the Google Drive. The link is posted in the comment section. The link for you to get the PDF is posted in the comment section. Please visit the comment section and see the link, follow the link, and you'll be able to see the PDF format of this. Thank you and God bless.